Hi, we're Physisaurus Rex, and our experiment is flipping physics. In this experiment, we're going to be comparing two different backflips and the rotational motion. The backflips are tuck and layout.
Here's Mike with a tuck. A tuck is when your radius is a little bit smaller because you're tucked into a ball and your mass is closer to your axis of rotation. Here it is again.
Now Mike is going to demonstrate a layout backflip. In a layout, your body is straight, and so your mass isn't centered around the axis of rotation, and so your radius is a lot larger. Here's another layout. Now Mike is going to perform a bunch of tuck backflips so we can take the times and average it out. You got it! Okay, I'm good. Sound good?
Well done. Mike? Are you in there?
Hey, how you doing? I'm just gonna check my mass. Yeah, 170 pounds. Let's go convert that to kilos.
We're going to measure Mike's radius now for the tuck.
This is my tuck position.
And there's 46 centimeters.
Perfect.
That doesn't matter if it says go. Yeah. Okay, so now I'm all freshened up and I weighed myself on the scale and I found that I weighed 170 pounds. It's pretty huge. So I used my conversion and I found that my mass is 77.1 kilograms, and Brittany had just measured my radius in the tuck formation, and we found that I was 46 centimeters, all tucked up like that. So using the conversion, I am 0.46 meters in radius in the tuck. Let's cut it.
I did.
Go.
So Mike did a bunch of backflips in the tucked position, and we found the average time to be 0.654 seconds as our average.
So then we have to find circumference, and to do that, you use the radius from the tuck, and so it's 2 pi r, and you plug everything in and you get 2.89 meters. And then after that, you take theta, which was 360 degrees, and you have to convert that to radians. So 1 radian is equal to 360 degrees over 2 pi, and that's equal to 57.3 radians. So you have to divide 360 by 57.3, and that ends up equaling 6.28 radians.
So to find the angular velocity, omega, you take the change in theta over the change in time, right here, and you end up getting omega as 9.60 radians per second. And then we need to find alpha, the angular acceleration, and we find that by taking the change in the change in omega over the change in time, and we end up with 14.7 radians per second.
Angular. Alright, now we need to find our acceleration that I was rotating at. So first need to find the radial acceleration and the tangential acceleration. So using the formula omega squared times radius, we find that 9.6 radians per second squared times 0.46 meters gives us 42.4 meters per second squared. Now for our tangential acceleration, we use the formula radius times alpha, which equals 0.46 meters times 14.7 radians per second squared, which gives us 6.72 meters per second.
The next thing we need to do is find the velocity. So in order to do that, we use the equation a rad equals v squared times, or v squared divided by r, and we took the a rad, 42.4 meters per second squared, and do out the math, and it turns out to be velocity equals 4.42 meters per second. And the next thing we're going to do is find the acceleration. We, for this, use the equation a equals the square root of a rad squared plus a tan squared, and that comes out to be 42.9 meters per second squared.
So the next step we have is to find I, the moment of inertia. Since Mike, we decided he was most like a solid cylinder with a axis through the center, the equation is 1/2 mass times the radius squared. So we plug in our numbers that we found earlier, and we end up with 8.16 kilograms times meters squared.
Okay, now we have to find kinetic energy. So, to find K total, you have to go 1/2 mv squared plus 1/2 I omega squared. So, these guys and these guys, right? M and I, they both equal centripetal motion, okay? So then, these guys and these guys, you add them up, and you add them all together, and then you have this, and it equals that, and then you get 1130 joules, and then that's kinetic energy.
Touchdown. Every time.
Okay. So here's Mike with a bunch of layouts.
Nice!
Okay, so we're going to go ahead and average those. Okay. Now we're going to measure Mike's radius for the for the layout. 104 centimeters.
Right here we're going to be describing Mike doing a layout backflip. After several trials, we found his average time to be 0.941 seconds.
So the circumference for that circle that I made, like with my feet, you know, we use the same equation, 2 pi r. Our radius, of course, changes because I'm fully extended, and that distance from the center of my mass to the far reaches of my appendages is a meter, 0.4, which is, okay, times pi times 2, which equals 6.53 meters. It's like kind of a weird way of saying that. So finding theta, of course, was the same since it was a full revolution, 360 degrees, divided by 57.3 is again 6.53 radians, like the other backflip.
The next thing we did was we found the angular velocity, and so we use this equation, omega equals the change in theta over the change in time. We plugged in the information, and the angular velocity is 6.67 radians per second. And the next thing we wanted to find was the angular acceleration. So we use the equation alpha equals the change in omega over the change in time, and plug in that information, and that turns out to be 7.09 radians per second squared.
The next thing we want to do is find the radial acceleration. And our a rad is velocity squared divided by the radius, which we found back there. And that yields omega squared times r. So our a rad is omega squared times r. We plug in our numbers, and we get 46.3 meters per second. The next thing we need to find is the tangential acceleration, or a tan, and we can find that by taking the radius times x, our distance, and A tan equals our numbers that we have, so we plug those in, and our final is 7.37 meters per second squared.
Find acceleration. So acceleration is the square root of a rad squared plus a tan squared. So when you plug in all the numbers, acceleration is found to be 46.9 meters per second squared. After that, you can find speed, and the equation for speed is a rad equals v squared over r. When you plug in, or you have to solve for v squared, and that gives you 6.94 meters per second.
Okay, now to find the moments of inertia for this layout backflip, we use 1/12 times mass times the length squared, because in layout form, this is the equation that closely resembles me as a long skinny rod, and we find that 1/12 times 77.1 kilograms times 2 times the radius equals 27.8 kilograms per meter squared.
Okay, then finally we're going to find the kinetic energy. For this equation, we use 1/2 mv of centripetal motion squared plus 1/2 of I in centripetal motion times omega squared. We plug this in for 1/2 77.1 kilograms times 6.94 meters per second squared plus 1/2 27.8 kilograms per meter squared times 6.67 radians per second squared. And our final answer is 2,475 joules. Here are a few more examples of rotational motion.
Something that you could slide about. Say for instance, my girlfriend, she loves me all the time, but the irony is, she loves me all the time.